Hello and welcome to
Hello,
this
hello.
week's episode of AWS On Air. How's it going, Fiona?
It's going pretty well. How are you doing, Am?
Living the dream. Any better, Fiona? I couldn't stand it. That's how good I am.
Gosh, I love hitting that upper limit.
Yep. So, all of you, tell us how you're doing. Glad to see you here. Glad that you're joining us. Welcome to the show. I'm A.M. Grabelny. I'm one of your hosts, and I am the absolute worst at self-deprecating humor. Absolute worst. Doesn't get worse than me. I'm also a dev advocate here at AWS. Excited to spend my Friday afternoon here with you all and with our new host, Fiona.
Arguably more excited.
Tell the people about you.
Thank you so much, Am. Hi, everyone. I'm Fiona McCann. I am hosting for the first time today. So excited to be here. I'm a solutions architect at AWS. I work primarily with nonprofits. I do a lot of AI ML work and responsible AI, and I'm just really excited to be here.
That is awesome. Now, look, Fiona, this is your first time hosting,
It's
but
true.
not your first time watching, I'm sure. What are the people in store for that have joined us today?
A lot of learning, a lot of laughs, a great time, I would say, just overall.
Living, laughing,
Living, laughing,
loving.
and loving,
Okay.
as my kitchen items often do say. Live, laugh, love.
All right.
What would
But
you
in the
say there,
cloud.
Storm?
But in the cloud. It's
Oh,
live, laugh, love, but cloud.
Live, laugh, love, AWS Cloud Edition.
I'm on board. I'm here with
I'm
you.
in.
I love
Sign
it.
me up right now, actually.
Okay. Today, actually, we're talking high performance computing.
hmm
We're going to learn a lot about that, which I'm excited about. I'm not an
Word on
expert.
the street is you might be a simulation. Is this true,
Mm.
Anne?
Yeah, I mean, you just have to watch and
I
see
have
if
to
there are any
find out.
glitches.
hmm
You tell me at the end.
Uh, uh,
Yeah,
please.
that's actually really rude of you to do
Sorry,
for
I
me.
take it
Like
back.
since I am a simulation. No, I'm just kidding.
It's kind of offensive to you. I apologize. I take it back.
Yeah, we're going to be talking with. There's an exciting new launch in the high performance computing space here at AWS. We'll be talking with Matt about that later. We'll also be hearing from our friends at NVIDIA, and as always, well, not necessarily always. We haven't had him. I think he took some vacation there, which can't believe. How
Lucky
dare
him.
you, Jeff Barr? But we've got Jeff Barr this week. You'll be hearing from Jeff Barr later. And you'll be hanging out with me and Fiona. Speaking of hanging out with me and Fiona, we are live with you. I'm in chat on our channels as you're watching. I'm here looking. I see that the Zero Sleep is fantabulous. That's
Oh, that's
it's
great.
great.
Fantabulous, one might say.
Very happy for you. Let us know where you're joining us from. Let us know what you're excited to talk about, excited to learn about. And most of all, when we are talking with the HPC people later on, let us know your questions. Right, Fiona. That's why we're here.
Yeah,
That's why
what
we
do you
do
want to
this.
know? What are you hoping to learn? Do you have
Wow,
experience with HPC? Keep us updated on what you're working on.
look at this. Jeff Barr's actively trying to get out of this show with us, Fiona. This is
That's
upsetting to me.
Is it because I'm here for the first time, Jeff? Did you not want me to be the host today?
It
My
would never
feelings
be you,
are
Fiona. It's he's
might
coming
be.
for me. But no, Jeff, you can't. You can't get out of this show because the people demand to see you. Speaking of, we are live in the U.S. Hero. So if you're joining us because you saw us in the U.S., we're getting ready to celebrate Labor Day, right, Fiona?
We are. How are you celebrating Labor Day, Am?
I've got a Spice Girls documentary queued up for this weekend.
It's a dream weekend.
Yeah, I mean, people of the world, spice
hmm
up your life. That's
Absolutely.
what I say.
Who's your
What
favorite
about you?
Spice
Oh,
Girl?
who's my favorite Spice Girl? Mel B. Yeah, for sure.
Good answer. And my Labor Day weekend, the weather in DC is very cloudy, stormy. It's giving fall energy right now, so I will be making some pumpkin baking myself. Is that a fall flavored latte I see?
Pumpkin spice up in here.
There's cinnamon in here, so a little bit fall,
Okay.
but
Okay.
I'm ready for the fall season to come in. It looks like it's a sunny weekend in Seattle right now, I'm seeing, which I grew up in Seattle. That is not normal for Seattle. So soak up that one day of sunshine that you're all getting over there.
Yeah, that's right. Now, as we get ready to welcome our first guest, I'll ask you all a question that you can answer. Is it too early for pumpkin spice? It's a very important question. So drop your answers in chat. It is, right? Age-old question.
Age-old question. I'm one of those people who I just think it's never too early to start celebrating the next holiday.
Let's do it year-round.
I'm ready to go. Make it year-round, zero sleep.
Zero sleep read my mind. I said the exact same thing. As zero sleep, typed it in. You and I, zero sleep, we'll make this happen. Make this happen. Let's petition the government. Make it happen. Okay, let's get our first guest in. Let's talk with Matt from the HPC team.
Slated for the weekend, so I'm headed for a festival in the north end, the Italian north end part of Boston, and then I'm going to find a boat to be on for the rest of the weekend. So
you jumped right in, Matt. You jumped right in. We didn't get to hear all your answer there because we had the music playing over you, but you were jumping right. I love
You're
that.
Ready to share your holiday plans with us, and I love that.
Ready to go.
Yeah. Okay. So
take us back. Tell us what you were telling us.
Sure thing. I'm not used to having a musical track. So
right?
I live in Boston. So I'm going to we've got gorgeous weather planned for the weekend. I'm going to a festival in the North End. Then I'm going to find a boat to be on for the rest of the weekend. So it's going to be great.
Going to find a boat. What's your plan to find a boat?
There are ferries. There are ferries. It's a water town. So.
Right.
I'm thinking he's going to commandeer a boat.
I think it's going to work out.
I'm not going to commandeer a boat. No piracy.
All right. Fair enough.
Yeah.
Welcome to the show, Matt. You want to tell the people a little bit about yourself? What do you do for AWS?
Yeah, so I'm Matt Vaughn. I'm a principal developer advocate on the HPC team. What that means is I help build HPC products and features, and once we build them, I help make sure everybody who wants to can use them. And I'm here to talk about the new service that we launched, which is AWS Parallel Computing Service, or PCS for short.
Yeah, I know we want to get into the exciting launch. But I think before we do that, not everybody, me included, are regular users of high performance compute, or maybe even know why we need things like high performance compute. Can we start there, Matt? You mind backing it up a little bit to that point?
We sure can. So you might not be a user, but you're definitely a beneficiary. So high performance compute or simulation is everywhere. And here's how this works. So like most natural systems can be expressed in really complicated sets of equations: fluid flow, climate and weather, materials properties, protein structure, all sorts of stuff. You can load these equations up in a computer and you can run them forwards or backwards, and you can inspect that system that they represent. That's why it's called simulation. So some examples of that. So when you buy a new car, it's been driven millions of miles before it ever showed up on the lot. That's how you know it's safe. That's how you know it's efficient. When you see a hurricane forecast with all those little spaghetti tracks, that's thousands of HPC simulations run pretty much hourly under different models and different assumptions and different conditions. And on a related note for Fiona, there's also people who every day run earthquake predictions.
I'm afraid of earthquakes for those who missed that context.
Me too. I live as far away from California as possible. And obviously they want to get to the point where they can actually predict them. And as I understand it, there's a lot of progress there. For the space fans out there, every new rocket engine, every design, and all the components that go into it also get flown millions of times before it ever touches a launch pad. And again, that's HPC. And these are just examples. Basically, simulations let you look into the future, they let you look into the past, and they let you look into realms that are too small to see or too big to comprehend with just your eyes. Thing is, this takes a lot of computing power. And there's really two ways to get that computing power. You can buy a bigger computer. Everybody likes bigger computers. Or you can buy more computers. The thing is with bigger computers is that they're nice, but they only grow so fast. and they're often really expensive as you buy the really bigger ones. So to really scale out, a lot of people pick more computers, a flock of them, if you will.
Yeah, what we need a term, like a murder of crows, right?
Yes, well, yeah,
What do you? I guess a fleet of computers is really what people
it's a
call it.
fleet,
But
it's a cluster.
I think we need
Yeah,
a more fun name, personally. But maybe chat
yeah.
can help us come up with that. So Matt, it sounds like a lot of scientists, a lot of oh, there we go, plethora of compute.
Plethora works.
Good,
Plethora
good
works.
suggestion, like that. Sounds like a lot of scientists, a lot of researchers doing this. I'm also a space fan. It's where I'm from. Great. We've identified who's using this, why they need it, right? A bunch of compute to run these simulations.
Yeah.
Why did you all build this, though? What's difficult about managing all of this? These
I'm glad you asked. Okay, so the traditional way you build a cluster is you buy a bunch of kit, you have it delivered in a semi, and you wire it together in your own data center. And I can confirm this is a lot of fun. I've done it a bunch of times. But the one challenge is you're locked into what you bought, even if your needs change. And that happens. Things come along like Gen AI or big data or genomics. And it's a lot, even if they don't, you have this thing in your data center and it's a lot of work to keep it up and running. It's a really complex system. So it makes sense that a lot of people are interested in using the cloud for HPC. And that lets you skip that lets you you can skip the semi truck part and the cabling part, and you can always rent more cloud. But you've got to know how to do all the cloud stuff. And a lot of HPC people don't actually know a lot of the cloud stuff. And you're still on the hook to maintain and scale that cluster up and down. So there are some do-it-yourself solutions for that, for HPC in the cloud, but that setup and maintenance is really the long pole in the tent. And that's why we built PCS. So with PCS, Parallel Computing Service, you go into the AWS console, you stand up a cluster, it takes just a few minutes. And we manage the hard parts while you still have control over the important stuff, like what software is on that cluster, what work actually gets done, et cetera, et cetera. What's extra cool is we help you make that cluster totally elastic when it's not doing anything. Like it's Labor Day weekend, it's time to pull the cord, quitting time. Who needs a bunch of nodes running? So in a PCS cluster, most of the time, those compute workers go away and they come back if somebody comes along and says, hey, I need to get a bunch of work done. And so that's also great for cost efficiency. There's a whole lot of other reasons for this, but that's the key thing. Easy to stand up a cluster, easy to make it elastic.
Very nice. Yeah. So look, I deal a lot in my neck of the woods with provisioning out infrastructure, managing infrastructure. That's my side of the house, right? I'm a DevOps person, so
Yeah.
I enjoy working with that. Anything you take off my plate, I'm going to appreciate. But something we were talking about earlier too, Matt, that I thought was important to call out about this. A lot of the people using these clusters are not necessarily like me. They are scientists, they're researchers,
That's right.
Arguably much smarter people than me. But they are not necessarily, well versed in working with infrastructure, right? They just kind of want to schedule their jobs, schedule their simulations, have them run. They don't care about how that happens, right? So, how does PCS help with that type of user?
Okay, so for that kind of user, there's the model usually is that there's an administrator who's responsible for the cluster. And they go and they do it however, whether they build it in a data center, whether they DIY it in the cloud, or whether they use PCS. They've got these end users, scientists, engineers, analysts. They just, at the end of the day, they just say, here's an IP address, log into this, and you get a console and you go do work. You can submit jobs to it, and we guarantee that the jobs will get done. You won't have to wait forever for them to happen. And so if I'm a end user, honestly, the interface looks a whole lot the same. I mean, it's just an IP address. You can put a custom DNS name on it or whatever, but who cares? It's just something that I log into. I can go and do work. But what's less likely to happen is, because that cluster is elastic, because the system administrator and all the decision makers upstream of that can dynamically change how the cluster works. it's less likely that I'm going to hear, oh, we can't actually accommodate that work. Oh, we could, but you've got to, you got to come in over Christmas and run that job. Otherwise, we're not going to be able to sort you. Or, oh, you've used too much space on the hard drive, or, all sorts, or, oh, we don't support that software. A lot of that is a lot easier. You're less likely to encounter that as an end user on a system that's managed by PCS.
So as an end user, my life isn't changing that much. I don't really need to worry about what's going on behind the scenes, but my life got better because now the system's working when I need it to and working more reliably than maybe it was before.
Yep, that's about right.
I like that. I like that as an end user.
Yeah, we wanted it really to just be transparent to those end users. They just, they wake up and they get a new present, and the present is a cluster that they don't have to wait on as much.
Fiona, I don't know about you, but I like to see this stuff. What do you think?
I'd like to see it in action.
Sure. So I've actually got the Parallel Computing Service console up. We can create a cluster, and then we can jump over to a cluster that I've already created and kind of kick around there. So why don't we do that? So here we are at the Parallel Computing Service console. This just launched. It's still smoking. There's still steam coming off of it.
I can smell it. It smells like fire.
I can smell it. Definitely. This is an exciting launch. So I'm going to create a cluster. We'll give it a name. You guys have a suggestion?
A suggestion for the name?
Sure.
Bird Flock 22.
Okay. All right. So we pick a
22 is important. I feel
22 is really important. Well, there were 21 other
Lucky number.
Yeah, so we pick a scheduler right now. So this is too much detail, but there's a bunch of there's a really common job scheduler that we support. In the future, there'll be different versions of this. Right now, there's only one, so this is grayed out. You pick your controller size. This controller, this is an abstraction that puts the management logic for the cluster in the AWS control plane. So you can basically pick how many instances you want to manage at any given time, or the maximum number of jobs that you want to support at any given time, small, medium, and large.
Okay.
So we're just going to pick we'll pick a VPC and a subnet and some security groups. And this is all explained real well in the user guide or my YouTube videos. And we click off create. This takes about 5 minutes. This is probably the longest part of creating a cluster. A whole bunch of stuff gets provisioned under the hood. This comes up and you get an interface. So let's look at OnAir 3. This is a completely done cluster.
Okay.
All right, so here we go, OnAir 3. I created it, as you can see, not too long ago. Here's all the information about its configuration. So you have this cluster, and the cluster is just the management instance. It's like a management instance and some control logic. We have compute node groups. These are essentially groups of workers. And if you look at them, you can see that they have a launch template, they have an instance profile, they have a minimum and maximum instance count. This is how you control the scaling. So if you set the minimum count to 0 and the maximum count to n, when there's no work submitted to the cluster, it scales back down to 0. And I'll actually show you that.
We had a question from chat real quick.
Sure thing.
Matt, if you want to take that. Is PCS integrated with LDAP or other user directory services?
You can integrate it, and in fact, there is a recipe in my GitHub repo for that shows you how to get started with that.
Okay, cool.
Yes, you can integrate it with LDAP. All right. So anyway, so we have a couple of compute node groups, and in fact, one of these is I've named them. One is on demand, one is spot. And then I put them together in a single queue called demo. And the demo actually has both of those compute node groups in it. So how does this manifest? How does it actually look to one of those end users who logs into a cluster managed by PCS? So there is a persistent login node. So this is just an instance that you log into to work with the cluster. That's actually, in this case, managed by that other compute node group called login. So I'm just going to log into it. I'm going to connect to it through SSM. You can also use SSH if you've configured your instances for that. It's going to become the default user. And the first thing we can do is let's just look at the file systems. So I didn't show this, but under the hood, I wired this thing up so that the home file system uses Amazon EFS. The storage capacity for the home file system is 8 exabytes. In case you don't know what an exabyte is, that's a lot of storage. What we've essentially done in this cluster is we've given everybody an infinite documents store, which is cool. Usually, HPC cluster users fill up their home directory, and it's a constant source of annoyance. Then there's another mounted volume here /shared. This is actually FSX for Lustre. So this is a really high performance file system. All right, so how do we interact with the actual job scheduler? So we can look at so there are commands. We can look at we can type sinfo, look at the number of queues. So remember, we created a queue named demo. Its status is up. You can submit jobs with infinite duration to it. It has up to 8 nodes. And the nodes that are in it are both the on-demand nodes and the spot nodes.
Nice.
If we had a job running, we could type SQ to see it. But instead, let's actually just kick off a job.
Let's do it. Yeah, and for those who live in this world, right? This is the job scheduler that comes with PCS. That's pretty common throughout the industry.
Very common.
Slurm, right?
Mm-hmm. Yep. Okay. The majority of customers of people use Slurm. There are other ones, OpenPBS, et cetera, but Slurm is the one that we support now.
Cool.
All right. So what I've done here is I created this is a batch job definition. It's not super exciting. We're just going to run what's called an MPI job. That's a way of distributing work across multiple nodes. I've said that I want to run on 8 nodes, and I just want to run this command hello. We can see that this is coming up. All 8 nodes are now configuring. Eventually, they'll transition into a state where they're running, and then they'll write out to a file. So what's cool is I could submit more work. So I can send this in again. I could also change what that job did. There could be other users on the system submitting work, and the jobs will just get queued up, stacked up in this queue. There could also be multiple queues, et cetera, et cetera. But what's going on under the hood, if we go back to instances,
is that actually spinning up instances?
Yeah, you're actually spinning up instances. So you can see
cool.
that they're initializing. Half of these, because this is the way I configured it, half of these are spot instances, half of these are on demand. And the way that I configured the cluster under the hood was that jobs go to the spot instances first. And then if we can't, if we reach if we reach the maximum number of spot instances, only then do we start placing jobs in the on-demand instances. And so that's right out of the gate in it would have taken like 10 minutes to go through this, but I didn't want to burn all that time when we could just talk. We already set up
your
cost-effective
cost. Yeah, optimizing your cost. Matt, I gotta interrupt for just a second. We've got another question from our YouTube chat. We got a question about using this for Python data science jobs with Streamlit instead of the terminal as the interface.
I haven't done that specifically, but I guess the summary story is if you can wire it up to any other cluster. So if you can wire it up to any cluster, an on-premises cluster or a hand-built cluster, you can wire it up to a Slurm cluster managed by PCS. And there are ways of doing this. Some job management systems need their own standalone node for managing them. There's a way of having a standalone job management node, or there's all sorts of ways. So I don't know exactly how to do it, but it probably works. A lot of our customers in the HPC space do a lot of Python and a lot of data science.
Nice. Cool. We got about 3 minutes or so left, so I just want to make sure we cover everything that you wanted to show us. So far, this is really amazing. Love that it's favoring Spot first. That's amazing.
Yeah, so these instances are spinning up. It takes a couple of minutes for them to spin up the first time. But here's what's also cool. So at the end of the work, so after the job has run, actually physically run on the instance, the nodes will hang around a little bit, and that's configurable at the cluster level. You can set it for 10 minutes. You can set it to hang around for an hour. If you submit a job again, it'll run instantaneously. But when the cluster detects that there really isn't anything else to do, it starts to spin down those nodes in reverse order from how they were created, allowing the cluster to scale back down to 0. And I really like that. Other things. So like we've got active work going here. So we've got 2 jobs in the queue. We could go back and I'm not going to because I don't want to curse myself, but we can go and we can change the configuration of this cluster. We could add more queues. We could add more compute node groups. We could do all sorts of things. And under the hood, PCS will update the cluster configuration without interrupting or pausing the running of those existing jobs. And that's really important for all of those people who have been, who are actively doing work. And then one more key point. So that's like the system configuration. Another big challenge that people have with do-it-yourself clusters, whether it's on-prem or in the cloud, is keeping the security posture up to date. So all the low-level fiddly bits in PCS, the system software, the scheduler, et cetera, PCS automatically updates those for you.
Very cool.
That's pretty cool. Matt, I feel like when you work on a project for this long, it becomes like a baby to you. I mean, you're like a mother bird. You've been sitting on your egg. You've been incubating it. What are you most proud of about your baby? If you had to have us walk away with one really incredible standout thing about this new feature, what are you most proud of?
Honestly, just that. Yeah, it still has some cosmetic rough edges. It's an early service, but it is just awesome to be able to go in and click buttons and get a cluster. I've been doing this as a profession for almost 20 years. I've built a lot of physical clusters. I've also built a lot of other cloud systems before I came to AWS. And this is what I have wanted to deliver to people for a long time. It's just really, really cool. And we're getting great customer feedback from it.
That's awesome. Everybody go check it out. We've dropped some links to learn more about this exciting launch. And Matt, look, birds of a feather, we flock together. So I hope we will see you again on the show when you've got something else to talk about over in the HPC world.
All right.
For now,
thanks.
We got to say goodbye. Thanks for joining us.
Thanks so much, Matt.
All right. There we go. What do you think? What do you think, Fiona? That was pretty neat.
I thought that was pretty cool. I like that he had that spun up for us already. We got to see the instances, existing, being spun up, already health checked. And it was cool getting to see it in action in the console. What do you think?
I mean, like all the stuff he showed us is a lot of management work without that service, right? So, spinning up things at the right times when workloads are spinning down. It's tough to manage all of that, right? It's not impossible, obviously, and a lot of us do it, but it's always nice to have that burden kind of lifted off by a nice new service launch. So
he seems to understand the needs of the end user too. I like that it's just basically unlimited data stored, so that end user doesn't need to worry about how many files you can keep. It's unlimited. Makes little rough edges go away.
Yeah, that was really cool. All right, we gotta talk about Nick's favorite thing to talk about. Nick, our producer in the background. We've got a survey for you all.
Ooh.
Right? Have you ever taken the survey, Fiona?
I've never taken the survey. Tell me about the survey, please.
Yeah, the survey is all about what do you want to learn? What do you want to hear about? What do you want us to cover on the show? How are we doing? How great is Fiona? right? I think
That's an important question on the survey, I think.
10 out of 10, for sure. So please, if you take the survey too, look at that. You can read it yourself. You don't even need me to say it to you, but I will. First 30 people take the survey. $19 in AWS credit, which is a very specific number. 19.
20 is too many dollars. 19 is just the right number of dollars.
I think Nick made it 19. That's how old I am. That's my age.
Of course, yes.
So,
AM is famously 19. That's true.
that's right. I've been
19
19
is
for a long
prime.
time.
Also, Jeff has pointed out 19 is a prime number. We like that.
Yeah,
Prime numbers are fun.
Yeah. If you're not incentivized by the monetary gain that you stand to benefit from answering these survey questions, do it for Nick. He's got nothing else. This is how he spends his
Only
Friday
thing he
night.
has going for him, please.
That's it. He wants to know what you think. Yeah. $19 is 2 pumpkin spice lattes. Yes, that's true.
That's true. If we're tipping, it's probably not even quite 2 pumpkin spice lattes.
Yep. All right.
These days.
While you are filling out that survey, stick around because we've got more stuff coming. We're about to hear from our friends at NVIDIA, and of course, you can't miss Jeff Barr joining us. So let's roll the clip from NVIDIA, shall we?
Let's do it.
Hey everyone, really excited segment here. We're going to be talking about NVIDIA TensorRT. This is an ecosystem of APIs for high performance deep learning inference, and also TensorRT LLM, which is also an easy to use Python API to define large language models, and a really exciting use case for it from Base 10. And so they're going to show you how it is that they're using it to help companies with inference. And I've got Amir here, who is the CTO of Base 10. So Amir, tell us more about Base 10.
Yeah, so we're a 5-year-old machine learning infrastructure company with a very singular focus. We do one thing and we do it well, and that is inference. Inference, for the folks somewhat new to AI, is the serving of the models, not the training and the fine-tuning, but the serving in production at scale. That is our singular focus, and then the value proposition there is that you get really 3 things out of the box with Base 10. You get peak performance, whether that's latency or throughput, and you get to define that. Secondly, you get very high reliability and availability. This is for mission critical inference workloads. And then thirdly, you get the cost efficiency out of the box. These models are large and very expensive to run. And so you really want to balance that peak performance with the cost efficiency aspect.
Yeah, that definitely sounds like you're using AWS for that scale performance, I can imagine. So maybe you can help the listeners understand how it is that you're using AWS.
Yeah, so really maybe I can break it down to like, what does it take to serve these models at scale? What does it take to serve the mission critical inference workloads for our customers, demanding customers, companies like Patreon and Writer and many healthcare companies as well, who are really relying on this kind of performance AI phone call companies. And it really takes 2 aspects to running these models at scale. So one is performance at the model level. In other words, is your model, imagine your model running on a single GPU, whether it's open source model or your custom model, is it performing as peak? So for example, for an LLM, are you getting the highest throughput that you possibly can? Are you getting the fastest time to first token that you possibly can? And so there's a lot of work that goes on that side. We've been partnering on that side with NVIDIA. You mentioned TensorRT LLM. We have a big product launch that we just did a couple of weeks ago that really makes it easy for the average engineer, really, who is more and more every day is being exposed to inference problems at their jobs, to be able to really create these customized engines that perform as well as sort of like low latency and high throughput as possible. And these engine, the building of the engine is really hard, and so this is why we built this layer on top of it. These engines are really customized for the specific that it's running at, like input and output max token count that it's running at. So that's some work that we've done over there, along with different attention mechanisms and KV cache mechanisms and Medusa and other techniques. So that's one aspect. However, that's not enough. Invariably, at some point, that model running in a single GPU is going to get too much traffic, and you need to horizontally scale it to be able to meet that traffic. That's not an ML problem anymore. That's an infrastructure problem. And that is where we rely heavily on AWS. We're big users of EKS on the Kubernetes side, ECR on the container registry side, heavy users of S3 as well. And so and a bunch of other AWS services, together, really they help us with that second aspect of running these models at scale, which is horizontally scaling the model when you get that high of a traffic, scaling it up when the traffic is there, scaling it down quickly when the traffic is not there to save our customers money. All of those things really come together. Both of those aspects are needed for running in production.
Really fascinating. I'd love to be able to see it. Can you show us a demo?
For sure. So let's see. I don't have slides. I'm just gonna treat everyone not as a sales prospect, but just as engineers who are just curious.
We love seeing demos.
Yeah. So really, there's two ways to get started with Base 10. One is, hey, I'm just exploring the different open source models and I want to use them. And so that one is really easy. They're just a click away. There's a library of pre-trained open source models that are ready to go. A lot of them have been really optimized as well. Like this one, for example, you can see the TensorRT LLM engine that it comes with, and it's like a click away for you to go to deploy and run it in a dedicated way within your workspace. But the second way, really the common way for us, for our products, for our use cases, for our customers, is the fact that they have their own models. There are some are models that they pre-train from scratch. We have foundation model companies using Base 10, and sometimes models that they have fine-tuned. And that's the way to bring those custom models to Base 10. The on-ramp to Base 10 is Trust, which is our open source model packaging and deployment library. We built this, open source this, other people have contributed to it, which is really cool to see. Works with different frameworks. Think of it as a very simple scaffolding around your model to get it ready for inference and auto scaling and everything else that Base 10 comes with. Maybe I'll show just a little bit of code over here. There is a Trust examples repo, which is like hundreds of examples of trusses built for different models. So let's go and take a look at one in particular. Let's just do Llama 3 8B instruct. I want to show you a real trust just so you can see it's not magic. It's not heavy. It's actually quite light. This is the trust for Llama 3 8 billion. The trust is just two files. It's a config that describes the environment that the model needs to run. There's advanced features around custom Docker images and other things. And then the second file, which is a Python class with just two important functions. A load that defines what the model should do when it first loads up. Download the weights from Hugging Face using your private access key. And a predict function. And this is your actual inference path, the code that actually runs when you call the model. This has more code because it supports streaming and some other things, but it's really not that heavy. And so once you package up your model, then it's one command to deploy it on Base 10. And then once you do, it shows up over here. This is a real model running in production. It happens to be Whisper, but it works similarly for other models too. So you can see over here, it's been put behind an API endpoint that you can call. Supports streaming, supports different environments for the same model. You can give it different hardware that you have access to. So we have access to all these different GPU SKUs. including the MIG H100s that really have been massively helpful for our customers in terms of cost, performance, trade-offs. And then you can configure the horizontal scaling. So here, for example, you can say, I want my model to scale from minimum of 9 replicas, maximum of whatever, depending on the traffic that it's getting. And then we can see it in action. So if I go over here, look at the observability for the model, so you can see how often your model is being called. So this one, for example, is being called peak like 20 times a second. But then you can also see how it's horizontally scaling. How many replicas is it bringing it up? And notice that when there's a lot of traffic, it brings up a lot of replicas to meet that traffic. And when there isn't, it brings down the number of replicas to save you money. You don't have to build that. It comes with that functionality out of the box. And importantly, all along, your SLAs are being met. You can monitor your P50, P90, P99, and you can see that like as the system behavior and traffic patterns are changing, as the horizontal scaling is kicking in and bringing up and down replicas, you're still meeting your SLAs. Lots more observability around CPU usage, GPU usage, anything that your model is logging. And all of this data, by the way, is not stuck on base 10. It's logs are structured logs, and the metrics are Prometheus-style metrics. You can export those to your own source of truth. All of that is supported. There's more to it as well. Maybe I will just show you just one last thing that we did recently that has come in really handy for a lot of our customers, is the Chains product. And here's the story about Chains, and I'll make this part really quick. So we kept hearing from our customers that, hey, you have this inference layer, the one that I just demoed to you, and that's all good, but that's not our use case. Our use case is not call a model, get the response, and run with it. Our use case is running multiple models in unison, in an order, in a series, and getting a response back. And the problem that our product had with that was that as a client, as a customer, you had to like call these different models one after another. Here's a real example of it. So we have a customer, Blend AI, great company, who are doing AI phone calls. Think about what it takes to make an AI phone call happen. You have to transcribe what the human said, give that transcription to an LLM to figure out what to say back to the human, and then give that answer to a text-to-speech model. And so if we went with our original product, the customer would have to like call the first model, get the response back, call the second model, get the response back. It's like all of that back and forth is adding a lot of latency. And for a use case like AI phone calls, latency is king. You have to be able to do all of those steps that I mentioned in under 500 milliseconds. And we really couldn't do that because of the additional network latency that the old system or the normal way of doing it one model at a time was adding. And that's why we built Chains. The Chains is more for multi-model inference that allows customers to define the sort of steps that need to happen. 3 different models, in this case, Whisper, Llama, and some text-to-speech model, and have these run next to each other. And instead of doing all of that network back and forth, then you can have these models run in a series close to each other, extremely low latency, and get the response back. So that's really enabled some use cases that honestly, truly were not possible before that.
Wow. I mean, it's really fascinating, just like the optimizations that you've done on the inference side and how you've been able to use AWS as well as being able to use Tensor LLM to be able to kind of help you with that infrastructure.
Yeah, it really takes both of those partnerships, both on the GPU and model optimization side that we've been partnering with NVIDIA, and also on the infrastructure and horizontal scale, where AWS has also come in very handy.
I'd love to also understand, as your startup journey, how the NVIDIA Inception program and AWS Activate have been able to help you. And for the folks who aren't familiar, both of those are programs that we have for startups to help them to be able to grow their business. But I'd love to hear from your perspective.
Yeah, Activate really helped us in the very, very early stages of the life of the company, to get us up and running, and not have to worry about too much, especially when we kind of didn't have anything and we were starting from scratch. Inception came in handy quite a bit later into the life of the company, especially as we started partnering more closely with NVIDIA on performance, and while performance domain, we were through Inception introduced to TensorRT LLM before it was announced, which was really cool. They gave us access to it, and then we contributed back bug fixes and other things, and that really put us on the right path for being able to really sort of like take the power of the work that the folks at NVIDIA had done with TensorRT LLM, bring that to base 10, and then make it easily consumable by the average engineer, as opposed to the sort of like LLM engineers and researchers. So if it wasn't for Inception, I don't think we would have learned about it until it was announced. I don't think we would have had the close feedback sessions with them, and thanks to those, I think that it really pushed our product forward, and really we were able to provide more value to our customers.
Wow, I love that you were able to get some hands-on resources to be able to help you throughout your startup journey. And I know we are almost out of time. So for those who want to learn more about TensorRT and Tensor LLM, you could go to the AWS Marketplace, and there's an NVIDIA AI Enterprise that you could be able to sign up for if you want to be able to utilize that. There's also an open source version. But if you also saw this demo and you were like, oh, I want to be able to use that, get the inference benefits, but without doing a lot of the extra work, because Amir's team has done a lot of the heavy lifting, that's where Base 10 comes in. So Amir, how can someone, if they wanted to just get started with Base 10,
Yeah, anyone can sign up and use it. It's the same product that I just showed you, but feel free to email me and I can give you more credit than by default accounts get. Amir@base10.co, and I'll make sure that you all get at least $250 credit, so they can deploy these models, have access to all these different GPUs to deploy and scale and load test your models for free, and then decide if this is the right tool for your job or if it's not.
Love it. $250 in credits. What more can you say to that? So Amir, thank you so much for being here today, and stick around. We've got more coming up on AWS OnAir.
Hi again.
We're back.
Hey, it's us again.
Hey, I missed you.
I missed you too. It's so crazy. So let's recap for anybody who's just joining us, Fiona. First off, we're your hosts. Hi, I'm AM.
I'm Fiona.
This is Fiona. We've established I'm a simulation, and also I might be from space. Kind of drop that in the middle of that.
That was dropped in there and then not really mentioned.
Nobody
deeply.
reacted. So also wearing my favorite brand, Anxiety and Neuroses. It's
Perfect.
kind of my brand.
I like that.
Fiona, anything you want the audience to know about you?
I'm drinking a non-pumpkin spice latte coffee. However, am excited about fall upcoming and pumpkin spice flavors to come.
Look, I live my life like every day is Halloween. So
that's my motto. And
I'm there.
That is
I'm
my
there.
motto.
We heard from Matt Vaughn from the newly launched service, AWS. I'm going to get the name wrong. No, I'm not. AWS Parallel Computing Service, PCS.
Yes.
And we were asked by chat earlier to give a little bit of a summary of that session. I could take a crack, and you can correct me on all the mistakes I make if you want, Fiona.
Perfect. Yeah, I'll just rewrite it after you give it a first
Yes.
draft.
Please do. Yeah, Info Crusader asked us earlier. So what from a high level did I just watch? Which a lot of people ask that question after they watch something that I've been a part of. So
It's just confusing. You really walk away knowing less than you walked in knowing.
yeah. So we were talking through high performance computing, right? Which, as Matt explained to us, is the way to scale out when the option of buying a bigger computer isn't a viable option, either for cost, limitations of technology, whatever, right? And so oftentimes, instead of buying a bigger computer, you buy a lot of computers, right? You spread them out, and then you chop up the work that you have to do into jobs, and then you schedule them on those computers.
Right. But that's a lot of work having to do that.
It is a lot of work, a lot of maintenance, a lot of things to manage. You got to make sure those jobs actually get out onto those computers, that they finish
Sometimes
running.
you might not have the right amount of capacity.
Right.
You don't know how to estimate that capacity.
That's right. I love it. So Parallel Computing Service, AWS Parallel Computing Service is a managed service to help you with that scheduling part, right? So it includes a scheduler. I believe Matt said it was Slurm, which is pretty standard for this industry. And it just kind of works, right?
It's the heavy lifting for you.
And it makes sure a lot of these things happen that you previously had to manage yourself. So
it makes life easier for the sysadmin because they don't have to do those undifferentiated heavy lifting tasks. And if you're the end user, it makes your life better as well because you don't see the differences that are happening behind the scenes, that you don't encounter any issues that might have happened because of the complications of that scale out.
That's right. Now, Fiona, you just used up our entire budget. We are only allowed one undifferentiated heavy lifting per show.
I will never say it again, Anne.
It's the only thing you can do. That's it. Just one. We only get, now I can't say it, even though I just said it to say that we used up. So now we have two. We can't say it in the next show. Anyway. Yeah. All right. So and Matt's giving us the thumbs up from backstage that we got the summary. So I feel accomplished. How about you?
I'm great about it.
I'm
feeling the coffee in my veins. I'm feeling the new knowledge in my brain. Life is feeling good right now, I think.
You're a poet. You don't know it also.
I know it. I even rhymed on accident.
Yeah. Okay. All right. We just heard from our friends at NVIDIA as well. I believe that wasn't NVIDIA. That was a company that works with NVIDIA and AWS. Bastion, I think, is how you pronounce that. And now, Fiona.
What's now?
We get to bring our old friend Jeff Barr. You gave the international sign.
International sign.
Yeah, nice. Okay. Let's bring in Jeff Barr. Let's hear his roundup of the week. Hey, Jeff.
Barr.
Oh, you muted. You
Oh,
muted,
no.
my friend.
I am not muted.
There you go. Now you're
anymore. Welcome to the show, Fiona.
Thank you so much. I'm excited to be here.
And
Welcome
AM, always good to see you.
well.
Yeah, this is always the fun way to wrap up the week.
Yeah.
Always
So what's
is.
been going on in your world this week, Jeff?
Oh man, it's been a busy week. Let's see. My wife and I celebrated our 42nd wedding anniversary 2 days ago.
Congratulations.
Wow,
Isn't that crazy?
congrats.
Yeah.
Wow.
Earlier this month, I hit my 22-year mark at Amazon, which is also crazy. So
Wow.
It's
always
anniversary.
a fun month of celebrations and anniversaries.
Wow.
Oh
Let's
my
see,
God.
we got going on. I'm getting ready for a trip to South America. I'm going to Argentina and Peru for AWS community events in September. So getting prepped
Wow.
for that. That's super fun.
Very nice.
And
Don't
let's
cry
see.
for me.
Enjoyed the last remnants of summer here. It's actually 80 plus and really sunny, and we're expecting an awesome weekend. I actually took the water taxi from Seattle out to Vashon Island yesterday morning, and it was unbelievably beautiful. I left the we left the coastline of Seattle at like 6:40 in the morning, and at 6:45 the sun rose above the city. It was like the absolute most spectacular way to start the morning. So
You got that boat that Matt was looking for. What are your plans for Labor Day, Jeff? We've been asking everybody.
oh, let's see. We've got some house organizing to do because we've got some construction about to start. We've got time with the grandkids. What else? Organizing, cleaning, getting ready for a family wedding happening next month as well. So there's we could actually use Parallel Computing Service here at home because we have literally 100 different things going on at the same time. That it's at that level of chaos where you walk from one point to the other in the house, and there are 17 distractions of, oh, I should be doing this other thing instead of what I'm doing. And by the time you get to your destination, it's like, oh my gosh, there's more to do than I ever would have thought. So
it sounds like all good things that you're doing, though. It sounds like an exciting time.
All good things, but trying to track them all is fun.
Yeah.
Adulting is one of my daughters likes to say. Lots of adulting on the schedule.
I'm learning how to do that.
Very demure, very cutesy Labor Day for you, Jeff.
I hope so. I hope so. No relaxing.
Nice.
We always say around here, we say it's just better to burn out than to rest, is an old awesome song. But you kind of like get to a point in your life, you're like, yeah, we could kind of take it easy. You're like, nah, just kind of keep going at it.
Sure.
Better just to keep working hard than to
just
burn
the candle at both ends. Why not?
Exactly.
I believe we had a poll up too for what your plans are for Labor Day in chat. So I don't think the poll's up anymore, but maybe we can share those results here in just a bit. Fiona, did I ask? Was I completely rude and never asked you?
Like what I was doing?
Yeah.
You did ask me, and that's when I started talking about fall flavors.
That's right. That's right.
And
but you didn't give us the answer, did you?
What the answer was from the poll? It sounds like swimming won, and that going to a concert was second. That's what everyone's up to this weekend.
Okay. Concert sounds good.
Okay. Well,
we actually have Bumbershoot is our big music festival here in Seattle, which is happening just down the hill from me. So
nice. I've been to Bumbershoot. Are you going to go?
We actually live close enough to it that we can hear it without going in.
Free concert.
Even better, yeah. Even better.
The comfort of your own home.
Cool.
Absolutely.
Well, you got some roundup of the AWS news for us, Jeff?
Yeah, I actually do. Let's see. Okay, so first cool thing is a nice addition to step functions. So I'm sure our audience already knows something about step functions. Let me just fiddle with my screen here a little bit. I'm going to just put that up instead. Hold on one sec. I want to just show. Let's see. What do I want to do? I got way too many buttons to push here. I want to push that button there instead. And we're going to talk about step functions. I need to make one more small change here and do that. Okay, there I am. Okay. How's that? Okay. All right. Is that cooler? Okay. So cool addition to step functions. So step functions, we launched them in 2016, and it lets our customers build distributed apps, often very complex. You can connect up a bunch of web and microservices. Could be like a complex business process or a processing pipeline for your bird photos or anything in between. And so to use step functions, you build up a visual workflow that has a bunch of steps like I show here. We call that a state machine, and it's represented in our language called ASL, the Amazon States language. So this has been around for a while, and if you're a dev or an architect, you probably have step functions as your part of your bag of tricks or bag of tools. So that's all existing. But what's cool that we just did is we added a new validation API for your states language. So you might actually use our visual builder to make your workflow, but you might build it programmatically. And so you do that, you make this a fairly rich, expressive bit of JSON that specifies your definition. It can get kind of complicated because your state machine can be complicated. So we have this awesomely cool API called Validate State Machine Definition, and it does a whole bunch of semantic checks on your workflow. You can get to it from the console. So this is really like the same validation API that if you're using the visual tool, it's calling this behind the scenes to validate your state machine as you build it. But you could also call it from an SDK or from the command line. So if you have like a CI/CD pipeline and you want to make sure that your maybe you've machine generating this workflow somehow, you can validate it. And it's actually pretty cool because it returns there's the function definition. And so you can integrate this into your development workflow, but it returns a whole bunch of errors as well. So you get all these warnings. It's actually got some I don't want to call it intelligence, but it figures out some possible common mistakes and tries to give you some indications. Like if you have used the wrong case on an identifier, it will tell you, hey, it's not looking quite right. It'll give you some warnings. It'll give you errors. So I think this is just a pretty cool way to make it even easier to use our use step functions. I think it's and I think step functions is really one of our cool parts of AWS. So that's my first thing.
I love it. Can I plug too? You mentioned building it visually. I like to personally use Application Composer to work with step functions. I don't know if you ever checked that out, Jeff. Application Composer, one of my favorite things that we've launched in the past.
I never get to build stuff.
Yeah,
I unfortunately never get to build stuff.
That's okay. But for those of you who are building, go check out App Composer because you can build step functions.
Yeah, my working day is this high-speed tour past a bunch of amazing stuff that at every point I look and say, that is so cool. I really wish I could just stop the flow of innovation and just have a deep dive into whatever this neat thing is. And fortunately or unfortunately, that never happens. My role right now is just like enjoy all this awesome stuff as it just flies on past at lightning speed.
Right. You learn one thing and the next thing's already out.
Yep.
Exactly.
What's number 2?
All right. Next cool thing is an addition to the location service. So here's my blog post I wrote way back in 2020. So the location service, we launched this in 2020. It helps our customers add maps and location awareness and other location aware services to their apps, stuff like geocoding and routing and tracking and geofencing. It lets you get access to maps from a couple different suppliers, including from Esri and from Here Tech. That's not new. But what we do have that's new is an SDK that helps our customers to migrate their existing apps from the Google Maps platform over to Amazon Location Service. It supports the most common and most popular API functions, especially those that are for maps and for places and for routes. And there's, as usual, this is a starting point, and there'll be more support in the works over time. So we'll drop a link to the What's New. I think that's one of Nick's jobs, right? Nick is supposed to be dropping links to these What's News in the chat. Hopefully,
you never know.
Actually doing that. You never know with Nick, right? He could be off hunting quail or something. So you just never know. And the last cool thing. You ready for one more cool thing?
Absolutely.
Okay. So this is an addition to the VPC IP Address Manager, which is also called IPAM. And so if you're running some like big complicated enterprise, which probably none of us personally actually are, you can do a better and easier job of managing your IP addresses. So you can configure contiguous blocks of Amazon provided IPv4 addresses. So your network management is going to be simpler and easier for stuff like ACLs and route tables and security groups and firewalls. So you can allocate entire blocks of addresses, and you of course have to pay for, and you can then use all those addresses in the block. It turns out you can get this in both the free tier and the advanced tier of the VPC IPAM. And if you're using the advanced tier, there's this other really cool thing is that once you allocate some blocks of addresses, you can actually share those across accounts. So you could think of some organization that has got a lot of services that need IPv4 addresses, and they're usually organizations, and they're like big and sprawling and complicated in their network usage. This ability to first allocate those blocks to make your management easier to do, and then just share them across accounts. I think both of those are like super, super handy and super helpful for those complex network setups. That is about all I've got for today. And Nick actually is going to drop a link to that in our chat as well. That is just about it. And got a couple more good things to do here today before I can actually wrap up and start in all my weekend stuff.
Well, thank you for not starting your weekend.
How about that? Oh, there I am looking at myself on the screen. How about that?
Jeff, thank you for not starting your working early because I know
No.
you threatened that in chat. But
Exactly. No. I do my absolute best to be here every Friday, regardless of what else is going on. But it's a little hard when I'm traveling. If I'm 6 hours of time zone away, I used to try to work 20 hours a day when I was traveling, but it turns out that's actually a really bad idea.
it's
So
not healthy. Yeah.
no.
Can I do some little cross promotion here with your location service
Here, why don't we just
mention
put-
here?
here.
So I run,
Oh.
and I'll be sure to promote all the other shows too, and not just mine. But I run a show here on the channel called Step Up Your Game Day. And next week, Jeff, we will be playing a game day that features the location service. Actually,
Amazing.
we're playing Project Fun, which is find a unicorn nearby. That's what FUN stands for, obviously.
Ooh.
And we're going to be building a front-end application that helps you map out the locations of all your unicorns, which is really important, I think.
I am always trying to figure out how to map the location of my unicorns.
You never
They're
know.
always lost, right? You can't find them.
So hard to
You
keep
know,
track
I
of.
actually wore my game day shirt yesterday. I have been participating in the reInvent game days since the very beginning, and it's always one of the fun things that I get to do.
Yeah, hopefully you'll be joining us this year too. We'll see.
I actually need to run. We have got an overdue package at our front door, and my wife will kill me if I don't go get it. We've got to run.
Get that back.
See y'all later.
Thank you.
Bye.
All right. Fiona, there you go. There's your weekly wrap up with Jeff Barr. How'd you like it?
I mean, it's sunny in Seattle, so the fact that he was on camera with us inside must have meant that he really cared a lot to be there with us. So I'm feeling honored that we got to spend that time with him.
He really tried to get out of it, you know.
And then there was a package at the door.
Yeah. Seems suspect, doesn't it?
Totally.
All right, we gotta ask people once again. Here we are once again asking you to fill out our survey, please. Please.
$19 could be yours.
We can start playing the In the Arms of an Angel right now soundtrack.
If you want me to cry, then you can do that. Otherwise, don't.
If people don't fill out the survey, I'll have nothing to do all
That's
weekend, you know? So please, everybody, fill out the survey so that Arms of an Angel doesn't have to play over my weekend montage.
Hello, everyone. There are lonely people out there, lonely people named Nick, and he needs human interaction, and he gets that through survey results.
Only people don't talk to me. I can only get human interaction through these surveys. So please help out a lonely AWS producer today and tell me what I can do better next week. I know it's a lot, but
It's everything.
that's why we're giving you $19. And it's definitely not because I accidentally hit the 9 instead of the 0 when I was filling out the request form for these codes. It was 100% intentional because that's how much I care about the audience. I wanted to give them a random odd number.
Shy Guy's letting you down. Shy Guy's breaking your heart right now.
No, Shy Guy. It's not too long. It's only like a minute. Please. The zero sleep. You've got my back. I think the monkey crying.
I think the zero sleep has done the survey. It just feels like the
so.
zero sleep has done it.
I will remember you.
Please. I will remember what you say to make this show better. Please be brutal. I love brutal honesty. I know we can do better. Let us know what you like. Let us know what you want to learn about. AM, you mentioned your show. I don't think people know. We've got a ton of other shows too. We've got stuff for security that airs every other week or so on Tuesdays. We've got stuff for startups on Tuesdays. We've got Under the Hood with Art that goes through compute stuff again on Tuesdays. We've got the Data Dive every week on Thursdays. We've got my show, the sports show, on every other Wednesday. We've been on a bit of a hiatus for the summer because most sports are off in the summer, but we're coming back September 23rd or 25th, whichever one that Wednesday is. It's going to be, we've got some good stuff coming up. So check out our other shows. Let us know in the survey what you want to learn about. Let us know why AM is your least favorite host and Fiona is your favorite host. We all know it, but you know, yeah, let us know, guys. We do value the feedback. We do want to know how we can do better. Now, guys, something else we need to let our audience know.
What?
Did you hear that something's coming up like after Thanksgiving? It's like this cool yearly thing. Have you guys been to Vegas?
Halloween 2.
That too. But
The
if you
sequel
guys
to
been
Halloween.
Vegas-
Sorry.
We've got some cool stuff coming up in Vegas this year. It's this little thing called AWS reInvent,
Tell
where
me more, Nick.
we launch more stuff at this event. It is mind-blowing. So many cool things. We'll all be there live. Yeah, zero sleep. We all want to go this year. And then we all will live by your name because I won't get any sleep. This is going to be so entertaining for that entire week. But come down to Las Vegas. We'll have a lot of cool new things launching, lots of awesome new demos. All three of us will be there hosting the show, so you can come give us a shout out at the desk. I'll be roaming around doing demo segments like a weird sideline reporter, so that should be entertaining if you want to give me a shout out. There'll be a lot of cool stuff there. Come by the desk, register for reInvent today. We'll go ahead and drop a link in the chat. Our other producer, who's way worse than me, will get that going in there. So you've been to a couple reInvents now, right, AM?
I believe, first off, I have to clarify something. I believe the other producer, Debbie, is much better than you, actually.
Definitely not. Definitely. Put it in the survey, folks. Nick or Debbie? I think we all know.
Debbie.
Please. What the answer
AWS officially has said that Debbie is the best.
Darn it.
That's true. Yes, I've been going to reInvent since 2017.
All right. Fiona, have you been to reInvent before?
This will be my very first reInvent.
Dang. All right.
Well, I'm really looking forward to it.
It's going to be a whole lot of fun. It's reInvent every year is pretty great. Oh, Jeff Barr, he's back from getting his package. I've been to all of them.
To all of them. Whoa.
Man, I got to say, I felt great seeing Jeff's doorbell ring and him have to run off camera, because I do that, I think, in at least one meeting a week. So it makes me feel a lot better about myself that it's not just me that has that happen. Oh, Jeff wants to come back. Here we go.
I'm back. Just to
What's
prove
up,
I
Jeff?
was
You've
not
been to
lying
all
to
of the
you. Here's
reInvent?
package. See, I got the whole package right here.
Perfect. Perfect.
Could have been.
I had 3 separate alerts on my doorbell and my sidewalk camera and my street camera to make sure that I did not miss this package.
It always happens like when you look away for a minute. They like run up, hit the doorbell, run away. I swear.
I actually had alerts, and my my Echo Show on my desktop, I was watching the camera as well. So I did not want to miss this package.
What was reInvent number 1 like?
Oh, I didn't know what to expect, but I have really amazing memories of the first one, because we have a long prep period with lots of planning. And when we've got all these awesome launches that happen at reInvent, we have this entire team that is sitting in this big room, and we have this like NASA-like schedule of like second by second what's launching and when to publish stuff. None of that existed for reInvent number 1. I had blog posts for the stuff that we launched, and there was no plan. There was no launch room. I was literally sitting in the audience on my laptop on the show Wi-Fi publishing stuff, until I realized that the people in the row behind me could probably see what we were about to launch. And so this was like the level of planning and security that we had for reInvent number 1. And it's a lot more fun these days when you're part of this really amazing, well-synchronized process. Mm-hmm. What I also remember, like walking into that first keynote room, up until that walking into that room, and I think we had like 6,000 chairs set up, was really the first time that AWS felt like wow, this is something truly like large scale. You like for years we'd been building it, we've been working on it, we're hiring people all the time, we're launching all these services. Clearly you get to see that we're progressing and having success, and you get to see the internal numbers. Nothing makes it real, but as much as like seeing all those thousands of chairs, like, oh, all these people paid to come here and see us. This is legit. Yeah. Like it was a really profound moment for me. And I can kind of like remember just walking in and seeing those chairs and saying, oh, there it is. Sadly, most of my pictures are pretty lame from back in those days. You don't realize just how much better cameras have become just in the last 12 years. But
did you have a selfie stick? That's what I want to know.
I don't own one now.
All right.
But that most of the pictures, like, Vegas inside is actually pretty dark. So the pictures look kind of dim and fuzzy, and it's like things have come a long way since then.
Yeah.
But it was actually it's super fun. It's the most intense week of the working year. You get to meet so many people. You get to say hello. You get to like take lots of selfies and just do amazingly cool things. And it's always a blast. Totally blast.
I remember this is going to be my 5th reInvent. I've been on the launch team since I came to AWS, so I've gotten involved right away with all that stuff. I didn't really realize how big of a deal reInvent was until I remember the first night of my first reInvent. I was like 23, I had no clue what was happening, and I'm walking out of this room like, okay, what is this actually? And there was a drum line of people dressed up like in all lights, like outside the entrance doing like a big show, and a bunch of people dressed up in dinosaur costumes for some reason. And it was this big thing. And there was a crowd of like 100 people watching. I remember thinking like, oh, this is actually like a fun, like kind of a big deal. That was the first impression I had of reInvent, was picking up my badge and seeing that happen.
What do we have to do to get you into a dinosaur costume, Nick?
That's actually going to be a thing that starts next week. If people want to watch our show next week, somehow I have lost the fantasy football league or something last season, and I have been voluntold that I will need to do whatever thing the audience votes on at reInvent. We've got a couple of ideas. Starting next week, at the end of every episode, we're going to have the audience vote what they'd like to see me do. Some ideas have been, I need to eat a full pineapple pizza because I'm Italian and that goes against everything in my DNA. Might have to put on some costumes, do some dances. It'll be interesting. So maybe I will be in a dinosaur costume. It's up to the audience. Start next week.
Start brainstorming.
We have to create a lot of fake accounts then to come in and influence.
Please don't do that.
Okay. All right.
Parallel computing.
I won't.
No. That's what parallel computing service is for.
Yeah, exactly. Don't abuse what we just had on today, okay? But guys, last thing here, we got to wrap the show up. Now, I don't know if the audience remembers this, but this is Fiona's first ever show. And little does she know that it is a tradition for a first-time host to take us out by themselves. So with that, we're going to drop off screen and let Fiona wrap up the show. So thanks, everyone.
Okay. All right. Well, looks like it's just me now. I had no idea this was going to happen. Thanks, everyone, for joining us today. This was so much fun. In full transparency, my hands were really sweaty at the beginning of this because I was so nervous. And as the show went on, it just was so fun. And now I feel settled in and I learned a lot. I hope you all learned a lot about parallel computing. That wraps us up for today. I don't believe there's any more content, and they really threw me in the deep end here. So I'm just going to cut it here and say, have a great day. Have a wonderful Labor Day weekend, and join us back again next week and start brainstorming what we're going to make Nick do at reInvent, because this was mean what he just did to me. So now we have to be mean to him as well. Have a great weekend, everyone.